All right. Thanks all. Thanks for coming out today. Today we're going to talk about job design best practices. So it's one of the most. It's one of the most. What's that? Okay. Okay. Yeah. I'm no, is there a mic? I don't. Yeah. I'll. So we are this session. Job design best practices has been one of the most popular presentations in our user group meetings. It's actually developed by my boss, who has worked for a long time on Talent Studio and talent products in general. So he came up with this the best practices thing. It's actually we're going to talk about 16 best practices, but there are more actually. There's 16 more, and he has written also blogs about it. So if you're these whatever you see today, you can actually even go online into talent blogs. If you type job design best practices, you'll get links to the same content. Okay, but it's a great content. I think we're just we're proud to have it. Like I said, it's been pretty popular among our user group meetings. So quickly, the agenda we'll talk about introduction. I'll just we'll give you a brief introduction of what we're going to talk. Okay, what is best practices? I want to lay the ground first in terms of why do we need to talk about best practices? Why do we need to talk about job design patterns? Right? We'll talk about that a little bit. Obviously, whenever we talk about job designs or jobs in general, we have to talk about SDLC. So we'll talk about SDLC, and then we'll get into the 15 best practices. Okay. And then, let's say this is one or two couple of slides where we'll talk about the secrets of building a successful job. Okay, and real quick, myself, I've been Nitin Kudikala. My name is. I've been with Talend for about for 3 years now. Before that, I was at PepsiCo doing MDM and data integration work over there. And before that, I was with Informatica. I was a professional consultant over there. I was there for about 4 years. So I had a lot of DI, MDM, DQ experience. Now I take up a lot of requests coming through for our Talent Cloud product, actually. So today we're not going to talk about Talent Cloud, but if you have any questions, we're here, the technical folks here too, other than me. Feel free to ask questions about Talent Cloud. We are happy to answer. Okay, but today, let's keep the topic. Let's talk about job designs for today. If you have any other questions, like I said, we are here even after the session. Just stop us and ask questions. Okay. All right. So let's get started. The question. Okay. We'll get started with the question. What is the best way to write a talent job? Okay. I think, in my mind, at least, it needs to be easy to read, easy to write, and easy to maintain. But what we have seen from our experience so far is that you can honestly actually just effectively only do two, which means that you can, if you're doing reading and writing properly, the maintenance part will get impacted, right? If you're concentrating on the maintenance part and also reading part, the writing part will get impacted. Writing as in like the ease of building a talent job. Okay, reading is the ease of developers to be able to understand your talent job. Okay, maintenance is after you develop the job, how easy to maintain the job 10 years or 5 years later. That's what I'm talking about, reading, writing, and maintaining. So effectively, not experience, at least, this is not just talent, like any talent, any ETL product in general, you can only pick two, right? So how can you decide which one do you want to pick, okay? So the answer here is, if the job changes over time, your priority should be too easy to maintain, right? Easy to read and easy to write, okay? If the job is unlikely to change, right? Priority is to make easy to.
There's such a thing.
What's that?
Unlikely to change. Is there such a thing?
Exactly. So if there is unlikely change, I mean, you want to make it easy to write, right? Easy to write, easy to read, and easy to maintain. Yeah, you're right. So If you have multiple developers, right? I mean, that's critical. If you have multiple developers, I've been in situations where there are like 15 to 20 developers, right? At that time, the readability of that is critical. You know, any developer should be able to open the job and try to understand what is going on in there, right? So if you have, and typically most of them I would think would be in that last category where there are multiple developers. At that time, you should really think about the readability and the maintainability, okay? Not the writability, right? Which means that you have to spend a little bit more time to actually develop the job in the right way, okay? So what is the Talend? If you look at the Talend Studio, so let me ask you this. I should have asked this before. How many of you have actually used Talend Studio? Okay, yeah, that's almost more than 50% actually. Okay, great. So you guys are already aware of the Talend Studio, right? So Talend Studio, you have your palette to the right, you have your all the components to the right, and also you have your project structure to the left, right? But what you're doing in the workspace in the middle, you're basically what we call you're painting the code, right? What that means is you're bringing in components into the workspace, right? And depending on what components you're bringing in, the code on the back end is getting generated that way, right? So whatever you add into the workspace, the code will change, right? So you have to think about just like any other application programming, you have to think about whatever you add impacts the code, the performance, the maintainability, the writability, the readability, whatever you add inside the workspace will change. So if you add something, you have to make sure you know why you're adding. It's pretty obvious, right? So we are not a big fan of monolithic jobs. Okay, that's really at the core of what I mean. If there is anything what you guys want to take it from today is that you do not want to do. You do not want to develop monolithic jobs, right? Which means that you don't want to build a job where people have to drag down for 10 seconds to go to the last component that you have added, right? That you have to break it up. You have to really break it up, and we'll talk about a couple of options that are out there that you can what's the best way to break up your code, okay? But the basics still count. I mean, obviously the functionality, their handling, the memory management, all that is still, you still have to think about it. But it's always a good practice to actually break up your jobs in terms of a different logic. That it could be functional logic or technical logic, whatever logic you can come up with. Break up the jobs. Okay, we're a big fan of that. So SDLC best practices, when we are talking about jobs, when you're talking about code, SDLC is critical, right? SDLC is huge for us. We have invested a lot of time, talent in general, to come up with the SDLC best practice. Okay, so when I talk about SDLC practice, I'm talking about code check-ins and code checkouts, right? How do you want to do branching and tagging, and how does that reflect into your Nexus repository, into your deployments, right? How does it reflect to your error handling? How does it reflect your maintenance at the end, right? Your production support. So you have to really think about all that thing. So your SDLC methodology will impact each and everything. Okay, starting from requirements, starting from development, the testing, the maintenance part, the production support, everything will be impacted by your SDLC process. Okay, so have the right SDLC process. Think about, I mean, if you are an enterprise customer, you have to think about, okay, what SDLC process you have right now with your application programming, your Java programming, your .NET programming, and can I actually use the same kind of SDLC methodology for Talend? It might not work. You might have to make some changes. So, but you need to think about that before you you go and actually put put code in production. You have to think about how you want to do SDLC. Okay, make sense so far? And talent architecture itself, I would say it's a little complicated actually. It's not very straightforward, but overall it's basically you're talking about clients and the servers and databases, right? So you have the clients on the top, which is a web browser for your admin console. You have the big studio where you're developing your code. On the server side, you have your job servers, right, where the job is actually running, and also your TAC Tomcat server, where it manages your users, it deploys your code to the job server, and things like that, right? So you can put security around it. That's a TAC, right? And on the down, you can see the databases they're all back. I mean, the MDM, the TAC, the job mainly are also backed up by databases. So you have the 3-tier architecture here. Okay, it's typical, but there's a diagram if you go to help.talend.com and say talent architecture. There's all these lines going I think this is the next slide. I think there you go. All the lines going. And it's a little complicated, but from the looks of it. But if you think about it, it's really you're developing the job. You're using TAC. You're actually running it on the server. That's it, right? On the job server, right? So it is comprehensive. So the recommendation is to understand how job server works. Typically, it's a thin agent running on your server. So why, how TAC works? Why is even TAC there, right? And how does the Talend Studio connect to TAC? How does and TAC? Every Talend remote project needs a Git repository. How does Talend talk to the Git repository? So there are few things that you really need to understand before you can start coding. Okay. That's why understanding the Talend architecture is very important. Just like what I said, SDLC. Understand the Talend architecture. We are spending a lot of resources coming up with knowledge base articles, coming up with the easy way for developers to understand how Talend architecture works. We're making it as simple as possible. Talend Cloud, I mean, when you're talking about Talend Cloud is very straightforward. It doesn't even look like that. It's very like 3 or 4 lines. That's it. So very straightforward. So we are improving it, but right now the way it is that way, right? So there's a tag, there's the MDM, there's the data quality portal. We have the runtimes and things like that. So anyone using Talend MDM here, or our Talend data quality? Okay. So I come from the Talend data quality. Not Talend data quality, but data quality background. Okay, so Talend is really a comprehensive data quality suite. There are some about 20-25 components in data quality palette. They are really powerful. Really, in terms of if you want to do address standardization, if you want to do first name last name standardizations, right? If you want to do matching, right? If you want to do profiling. Right? If you want to understand, if you want to quickly run a report, understand the different patterns, like how many different types of zip codes do I have in my data, right? How many different types of email addresses patterns do I have in my data? You can within the studio, you can actually switch to perspective, go to profiling, and right-click on a job and say, run the profile for this table. It's going to generate a nice, clean report for you right then and there in the studio. Okay, but it's not available for Open Studio. It is available with the commercial product, but it's very comprehensive, very powerful if you guys want to leverage it. Because we don't market it as much as we should. I talk to a lot of customers. I talk to maybe 3 or 4 customers every week, and when I tell them we have Talend data quality. Have you used data quality for this particular use case? And they're like, data quality? I don't know. I didn't even know we had one. So if you try to leverage it, you do need, I believe, a platform license to be able to use data quality. Okay, it is just a little above the enterprise licensing. Anyway, so yeah, use that. Data quality is one of our strong things actually. So go ahead, please.
Well, we introduced it to one of our customers, and they were using 4 different products, and they were saying that they had to move stuff from database to database in order for their data stewards to work. And they started using Talend, and the amount of time they were actually able to take 3 or 4 data stewards that they were no longer using and move them on to other things that they needed to do.
Awesome. Good to hear. Yeah, that's a great success story. Great story. Yeah. So, yeah, let's move on. Oh yeah, continuous integration. So again, this is the same SDLC paradigm which you're talking about. So we're how many of you know what is continuous integration is? Okay. Yeah, that's about 25%. Sorry, say that again.
It's called that.
Yeah, exactly. So yeah. So. One of the big advantages. So I worked on Informatica tools. I've worked on I've worked on SAP Data Services tool a little bit. One of the big advantages of Talend is that you're combining application integration with data integration. Really. So CI/CD was really a concept for application integration, right? For Java programming, where you're building applications. Every time you have to make a simple change, you want to make sure the build is correct. So, and every time the build is correct, you want to quickly run some tests and automatically deploy to your production environment, right? That's high level how CI/CD works. So that is really an application paradigm. You can do that using Talend products. Because all we are is a code generator. On the back end, we are just we're just generating Java. So you can develop a job, right? You can develop a job and you can have a Jenkins workflow. I don't know if you guys have heard, but Jenkins is the most popular pipeline in the CI world. And you can build a pipeline where a task inside Jenkins will actually build a job for you and then make sure it compiles and automatically publishes it to your production server. So that's really at the high level there's a lot of configuration involved. I'm saying at the high level that's supposed to work, but there is some configuration involved, but you can make it work. I was at a huge enterprise customer in New Jersey, and they have successfully implemented CI/CD for their requirements, simply because they have so many production fixes, and they're going to production every day. They have production releases every day. So they cannot, there's too many manual things where someone has to test it, someone has to make sure the build is correct, someone has to actually deploy it. They want to automate that process as much as possible. So they started the Jenkins, they implemented the task, they created a task in Jenkins, they install everything like in a CI server. So you can do that if you want. So that's really, a great way that you can use Talend for, simply because we are a code generator. Though we are an ETL tool, we are just a code generator on the back end, right? So the development. So yeah, there's some foundational precepts we're talking about when I talk about SDLC, right? We're really talking about what you need to keep in your mind while you're developing the job in Talend, right? There's so many of them. From my perspective, there's if you want to prioritize it, there's nothing you cannot really prioritize. Every single one over there is important. There's a lot of them, but you have to keep these in your mind while you're developing the code in Talend. Okay. So readability, writability is up there, but again, you have to think about scalability. You have to think about consistency, right? We'll talk about that a little bit. We'll talk about efficiency, compartmentalization. We'll talk about that a little bit. So all these are important. So it's a pretty long list, but we do need to think about those when you're developing the code. Okay.
What the layer reading means?
Sorry, say that again.
Layer reading, bend but not break. What does it mean?
Creating code that will bend, but not. But I think it's talking about error handling. It's also talking about. It's talking about error handling. It's also talking about making sure sometimes the requirements are like you do have to build a big job sometimes, but at the same time you have to take some control. You have to put the right controls in there to make sure it does not break, right? You can make exceptions and actually create a huge job, but again you have to make sure you put enough control so that you don't break it. Okay, does that make sense?
So you mean like exception handling components are there?
There are error handling, exceptional handling components. Mike, you want to say something? You said.
I was just waiting. Sorry.
Okay. Yeah, we obviously have error handling components. We'll talk about that a little bit in the
We
seminar.
need to use those too.
Yeah. So, all right. Again, standards are important. The development guidelines document is very important. I don't know, does anyone use a guidelines document, like a technical design document or a functional design document? So I've seen some of the people do. Yeah, it's so my first job. When I joined, this was my first job. When I came into that firm, I mean, they already had they had a ETL data warehousing project going on for a long time, and I came in the middle. I did not know what to do. Where to start. If I'm developing a job, okay, where do I, what should I name if it's Informatica? So how do I name my source qualifier? How do I name my expression transformation? Is there a standard for that? How should I name my job name? Is there, what should I just say, job 01? Can I say that, or should I put in some conventions around it, right? So yeah, I mean, having a technical design document, will help because you're putting standards in your team, okay, across for your jobs, and also for your SDLC process. Oh yeah, there's a handout. I'll see. Yeah, instill good habits. So you can obviously start easy, and then for the same example, we start off doing a standard document. We start off putting in some information in the Word document, and initially it was like 2 pages. That's it. It was like 2 pages, and it was like, okay, let's start naming the job like this. Let's start naming the expression transformations like this. In like an year, that became like a 70-page document, right? So start off simple. I mean, you can just open a Word document and start typing some things. Believe me or not, that will grow in within like 6 months and a year. It'll grow like number of pages, because you will come up with all these things. Oh, I already have this standard for this one. I need to have a standard for this one too. How do I, what are the different things that I need to do to in a job server for scalability, for maintenance? What should I do, right? Things like that. You can just put in some information over there. If you're talking about Nexus repository, how should I name the repositories there, right? Should I put it in the snapshots repository, releases repository? How should the deployment work? So if you can start off, things will you will keep adding to it, and any developer who comes in later on, will easily be able to understand what he should do to develop that job. So it's a lot of work, but believe me, if you think in the long run, it's gonna have a lot of value. It's gonna show you a lot of value. Okay. I mean, these are really just basics. I know you guys are all already know about this, but I want to stress it. Sometimes if someone says it, you actually go do it, right? So that's why these are all, I'm pretty sure you guys are already doing it, but I want to make sure we talk about that. So let's talk about the actual best practices itself. So the first one is the interesting one. This is people will think this is a trivial one, but it's not. It's really not. How do you want to oh yeah, this is talking about the job design patterns itself. Sorry, what are job design patterns, right? So it is really a skeleton, right? So you can if you have a data warehousing project, right, you will have you can design a pattern for your for, let's say, you're moving all your stores data staging, right? There's no transformations involved. It just stores. That's one pattern, right? That's one pattern. So how do you design that pattern in Talend, right? That's one job design pattern. So things like that. If you're moving, let's say, if you're now from staging, you're moving to another layer in the data warehouse, right? So you will put transformations in there, right? In the transformations, okay, if you're doing like sorting, right? And you're doing the same kind of sorting for all the different sources, so you would want to use the same kind of logic, right? That becomes a pattern, right? So the moment you actually develop a job, you have to think about, okay, is this going to be reusable? Can I, will this be used for other projects or the same project but a different source system? You have to think about that, and that way you can build your own design patterns. Okay, and you will get that. I mean, if you think that we need a pattern for this, if you think that okay, maybe there's another project who will do the same kind of thing, and maybe we should make this job a little more generic so that others can use it too. There you go. You'll have a pattern right there. So. Yeah. I'm talking about joblets. I mean in general too, right? I mean error handling, like logging. How do you want to do logging? How do you want to do error handling? So let's say you were, like I said, you're just ingesting data. You're just doing truncate and load, right? And that could be one job design pattern, right? So, or if you're in a data warehouse environment, let's say you're doing a SCD1 or SCD2, that's one pattern, right? And you should not be. If you have two different sources and you're loading into the same data warehouse, right? These two different sources should not be using different logic, right? You should have the same pattern, right? That's really what we're talking about. Okay, it should look up the target. It should look up the dimension table and try to see what are updates and what are inserts, and so that you can send inserts in one pipeline and the updates in another pipeline. That's a pattern right there. That's a great example. So think about if you can find those patterns in your job so that it's easier for you. It'll be easier for you to use it for the other projects coming up. Okay. All right, practice number 1. Like I said, this is probably a trivial one, but it's not really. How you want to organize your components in your Talend job. It's important, right? It's very important. That's how we prefer our customers to develop their Talend jobs. Okay, we want to see the top to bottom and the left to right thing. Okay, so. If you guys already know Studio, but when I'm talking about left to right, I'm talking about on component OK, right? We are basically you're on sub job OK. So on some job OK will be from top to bottom, actually. So the left to right will be you have a source and you're sending data and you're transforming it and you're sending it to a target system. That's one left to right, a pipeline. Okay, and then depending on that sub job, that becomes a sub job. Depending on that sub job, what do you want to do, right? If everything works fine, you want to read a second table, right? And you want to do some processing and load a different table, right? So that kind of dependency. So that's how we want to see it. This, I'm telling you, I see a lot of Talend jobs. I'll say 70% of the jobs that I see do not do this. And we always tell them, okay, one of the jobs I do, I have to actually review job designs for our customers, and they send me the job actually, and they say, can you take a look and see if they can be any improvement be done in terms of performance, in terms of maintainability, in terms of readability, can we do something, right? So I look at the job and I'm like, I don't know what you're doing. I have no idea what you're doing. Even if they send a paragraph saying that, okay, this is what the job doing, even then I don't understand what the job is doing. So yeah, if you want to have any standards, start there, right? Anyone is doing this already, or is it something new or something?
Yeah, we are doing
it. Okay. Yeah, that's good to hear. And feel free to ask questions if you have any questions. The best practice 2, we're going to talk about job modules, like you said. We want to avoid monolithic jobs, right? Obviously, they will perform poorly. We've seen so many times it'll perform poorly. Even your studio sometimes gets really slow because it has to open the whole thing for you, or there so there's so many things that you can. There is negative factors if you do a big huge job. So so we have the subjobs, right? Use them. Subjobs is, so the other thing is talent job by default is single threaded, right? And you can make it multi-threaded using the subjob. Okay, you can actually, what that does is actually it will start a new JVM for you, and it'll actually process that job in that JVM. So if you have if you have a parent job or one sub job, you're gonna have two JVMs running on your job server. Okay, you can make it multi-threaded. In fact, you can even set the minimum and the max memory on the job specifically, just like any other job. You can set it for the sub job too. But again, we do not want to go like too many sub jobs. Okay, if there are too many, I mean, you can have too many sub jobs. It's just that you don't want to. You don't want to make it too complicated. Maybe the way is you can design it in a different way that you can make it in a single job, but you know what I'm saying, a single job, but not use too many sub jobs. But overall, I mean, overall, what I want to say is basically use the sub jobs for your benefit. You have to check that box. I don't know if you can do this. No, I can't. There's a small checkbox over there. Good. Use independent process to run subjob. That if you check that box, it's gonna actually generate a new JVM. Okay. Do you guys already know about this, right? New JVM and all that. Awesome. Good deal.
Explain actually, how do we do that? Subjob and the new thread.
Say it again. Sorry. What was the question?
How do we do that? Like, how do I invoke a new a thread?
Oh yeah, you just have to check that box over there, right? So the call child job over there, right?
Okay.
That's a subjob right there. Okay. And for that, in the setting, it's a use an independent process to run subjob. There's a setting there, and you just have to check that. That's it.
Okay. And the same line, right? When you're saying like break it into smaller jobs. Let's say I have three, like insert into staging, then into a new layer, and like three insertion. Should I keep it as one job, or should I be like three jobs?
So you would want to create three jobs for sure. You do not want to put it in one job. You can make what you can do is you can make three jobs, and you have one parent job which will control the three jobs. So on the parent job, you'll only have subjobs. It won't have anything else. It will have just subjobs in there. So the first subjob will actually make a connection and so you can. The first subjob will take the data from your source system to your staging, and the next subjob will take the staging to your intermediate data warehouse repository or something like that. So yeah, my recommendation will be basically one job with three subjobs in there, and you can connect them, right? Just like how you can connect them using unsubjob OK. You can connect them. Basically, you can put logic in there, right? You can say only if this job runs. You can load. You can go run the next one. You can put the logic in there, right, like that. That's one example. But people have done what they call execution plans, right? You can do the execution plans way too. But I like this thing. I like doing the studio way. Execution plans in TAC, Talent Administration. Anyone uses execution plans in Talent Administration Center? So yeah, that is also a similar thing, but that is, I would not use that for your instance. I would use it only when there's a lot of dependency going on. If the job itself could become really big if there's a lot of dependencies across multiple jobs. At that time, you want to take some of that logic to TAC and run from there. Okay, and in there also you'll get options like, okay, if I run this job only if this job runs and things like that. And also if you are running like independent jobs, I mean functionally independent jobs, right? And you want to run them as an execution plan, you can do that too. You can put that in execution plan too. So, and also he's talking about the maximum nesting setting is 5 or something. So you can call a subjob within a subjob too. Okay, you can go like you can create like a tree actually. So you can call another subjob from one subjob. Okay, but again, if you do that, you have to keep clicking and going into the next job and try to find out what is going on in there, right? So the readability will suffer, right? The maintainability will suffer too. So, so our recommendation is try to have, I mean, it says 5, but try to have maximum of 3. In fact, I've never seen anyone do more than doing 2 actually. Just one sub job is fine. Yeah, 2 should be, yeah.
One will be the wrapper and other will be sub job.
Exactly, exactly. So, and that, I mean, you can use subjobs for orchestration too, okay? So one of the things you can do with big data, right? If you have, if you're using big data, right? There are some, as you might already know, that there are some transformations, there's some components only available in the DI perspective. They are not available in the big data perspective. If you immediately, if you go right click and say, create a big data bad job, some of the components will not be available, right? What we recommend is try to build the sub job, build the big data job the way you want, but some of the components that you want, take that logic to the DI job, right? You can orchestrate it from the DI job. You can put that logic in the DI job and call only the Spark job only whenever you need. So you can use the DI perspective for orchestration, right? That's one way to get around that limitation. Why we have not implemented all the components in the big data job, big data perspective, it's basically we did not. First thing is testing. We probably didn't test all the components. The second thing is it just did not make sense. Some of the components to be part of the big data job, basically because there's no Spark API which can handle that kind of logic and things like that. Okay, obviously you're building a Spark job, right? So it has to make sense for Spark, also when you're doing this kind of orchestration. Okay. Again, I went on a tangent a little bit over there, but that's okay. All right, joblets versus so when you're talking about this is really talking about reusability. There are 2 ways. Okay, we already talked about the T-run job, which is a sub job. Okay, you can call other jobs within the same job. There's also something called joblets. Okay, joblets is well, the biggest difference from the code perspective is that the joblets code is actually included. Okay, it's actually included. If you go to the code in there, it's all the code from the joblet, you will see it in there. It's all already included. But if you're doing a run job, you'll see a call to it, just like how you're calling a function, right? You actually will see a call to the job instead of including, right? From the performance perspective and all that, it really does not matter. This is just informational, really informational. But for orchestration, I'll say use the sub jobs. Okay, for anything like reusable logic. Okay, like I gave you an example. STD1. Those kind of logic. You can create a generic logic for TMAP, right? And even have like lookup tables. You can make that generic. That you can have that as a joblet, because it does not have a source, right? You're not actually processing data. You're just basically, it's a template, right? So joblet is just a template, okay? T-run job is basically you're actually running the job. So it has a source, it could have a target and things like that inside a job, right? Typically you need that. So yeah, that's when you will use joblets for. And the great example is the log processing and also error handling. If you are thinking about doing a common, you should have, doesn't matter if Talend or any other ETL tool, if you're thinking about error handling, it has to be a common way. Okay, you cannot have different error handling ways for different jobs. You have to build one centralized way that you can do error handling, and you would have to use it in each and every job. All you do is just take it and then put it in there. So for example, there's a joblet over there, log processing. It's you build that and you just place it in that job wherever. So log processing will take care of some of the logging and all that for you. Okay, and similarly, error handling can be a little tricky to do that, but you have to have some general generic error handling, and that you can do joblets. And then if anything specific to that specific component, you can do it within the job itself. So these are some of the common use cases for joblets. Okay, you guys are using joblets? Okay. Okay, good.
Joblets and actual component.
Yep.
And the benefit of that over calling it from a T-run job?
There's no really a benefit. I think it's a.
I mean, you're comparing the T-run, calling a child job versus doing it all in a sublet, right?
Not doing it at all. So for me, in my, I would use joblets. Like I said, it's only for templates. Okay. There's no in terms of performance or efficiency. There's no big difference, honestly. Okay. It's really for if it's template. If they say if you're building a template, use it as a joblet. Okay. If it's actually a proper job, if it has a source and target, you're actually processing data, right? And if it's a lot of data, you wanna try to execute on a different JVM, use the T-run job. Okay. But you should not call a job for error handling or logging, basically because it's not really processing any data, right? Those kind of things, they have to be part of a joblet, right? Any reusable logic, transformation logic, any reusable transformation logic, right? If you think about it, you can have a very generic, if you want to go through the same matching logic for different databases, you can take that logic and then put it in a joblet, so that you don't have to cut and paste in every single job. You
So
just
if you have a error handling side of it, and basically you have 5 components that does your errors, right? And you put it into 30 jobs, this job. So can you still change it, and you will all cascade into
yes,
all the other?
that's exactly why you would use it. Yes, that's exactly why you would use it.
Rebuild the job, like use the job. Because it's like old style macro, just some piece of code that is common across all the jobs.
Right, but the challenge usually tells you want to go ahead and cascade it, right?
It'll give you the warning when you change the job.
But it will do it. It will cascade it. Yeah, that's really why. If you guys know Informatica had shared folders and maplets. I think maplets. Yeah, maplets. Yeah. Similar to that, yeah, joblets, yeah. So.
And this is typically for like error handling.
Yep.
Error handling log.
Exactly. Yeah. Exactly. Yep. Exactly. Number 4, we are talking about entry and exit points. So there are a couple of components: T pre-job and T post-job. You guys using them? Anyone not using them in your job? So T pre-job and post-job should be there in every single job. Okay. T pre-job gets executed first when you actually running the job. Okay. So a common things that you want to do, like there is an example here, the pre-job. You see over there, the pre-job. I mean, you guys might not be able to see it, but it's actually opening a file list and then processing the file list.
But we have connection components, right?
Right. So yeah, you do. So so the connection components, you can stitch it to the pre-job, so that you're validating the connection right then and there. It's not even going to the next step, right? So all the connections should be part of the pre-job, or you can. That's one good example. Other good example is if you have context variables, right? If you wanna load all the context variables, you can use the context variables in your pre-job too, right? You want anything you want like initializing, right? If you're writing a program, you're initializing actually some variables. You're doing some pre-work, right? Before you actually read the data, right? You have to do some connection checking. If the file is there, like for example, what's showing over there, if the directory exists. Things like that. You want to do the error handling right then and there instead of, there are uncompounded K errors and all that, right? But this organizes it. People will know, for anyone else it's easy to understand, okay, the pre-job, we are doing all these checks here, and then the main loop is where you're extracting data from your source and you're loading into your target, okay? Similarly, there is also a T post job. T post job is your closing connections, right? You open the connection, right? You have to close it, right? So closing connections, dumping context variables, you want to put them in the T post job. That T post job is what will execute at the end, okay? And so these are And as you can see, they are in the green color. That means that is either a job entry point or exit points. I did not know that until I saw this slide before, actually, 3 years ago. So because I was doing all this development, very unorganized, right? So you can organize it. You can organize the job this way. Have a pre-job, and believe me or not, a lot of what I see, a lot of jobs, they don't have it. And it's a good practice to have it. It's a really good practice. It organizes your job. You know exactly, anyone who is looking at the code understands what's going on, right? That makes sense so far? Okay, sure.
How is the connection happening to the pre and post from that picture?
Oh, there's no connection.
So which means the first step will be pre-job and then
Yeah.
whatever in the order it runs?
Yep, exactly. So the pre-job will run first, and then there will be a main loop. Actually, the call jail job is a main loop, right? That's what is actually reading the data and doing the processing. And after all these two steps are done, it's going to call the post job.
So how does it understand? Like just by looking
No,
at
yeah. If you organize it like that, the job server will know.
What was the question? Sorry.
Sorry, the question was how you're not connecting the pre-job and post-job. How does Talend know that post-job has to run after these two steps? It automatically does. That's why it's called pre-job and post-job. It's built.
One thing to note is the post job runs irrespective of whether the job succeeds or not.
Okay.
Post job always runs. So because we had a job failure, and then we noticed that the post job was still running. So I don't know.
You had a failure in the main loop, and even then.
And then still the post job was running.
Yeah. So I'm talking about the sequence. I'm not talking about the error handling itself. I'm only talking about the sequence.
Yeah. So your pre-job establishes all the connections.
Yep.
And then your main loop does the logic.
Right.
But the main loop fails. The job should exit, right? But that didn't happen. The job failed, but it still ran the post job.
No,
logic.
you would always want to run the post job.
Yeah,
Your main
the
job
post job is
fails,
closing the
you still
connections
need to try
from
catch
the
databases.
Yeah, because we had an update statement as part of the post job, so yeah, that was a bad.
Yeah. So yeah, those kind of things should not be in the post job. Yeah.
We learned it that way.
Any data updating and inserting, you don't want to put in the post job. Yeah, exactly.
only closing connections.
Or like context variables, dumping the context variables. And you also have the T-warn and T-die components. Use them effectively. They're there for you to use. I think they are the most effective component that you can use for error handling, right? I mean, you can put some messages in there too if you want. You can do a run if for some of the links over there. It's pretty. You would want to use them if you're building a Talend job. I want to make sure you guys know that there's these components that are there so that you can use them. Okay. Oh, you didn't know about the T-warn, T-die?
Pre-job, we are using components, the connection components.
Okay, but you do know about T-warn and T-die components, right?
Yeah.
Okay, good.
Pre-job,
All right, cool, good. Number 5, you're talking about error handling. We already kind of talked about this. Common error handling. Again, have a common error handling. Is anyone doing that? Common error handling. Okay, good. And this was the same thing when I was with Informatica too. The same thing. We used to have always a very generic error handling method, and we used to use it in every single job. Okay. Build return codes if you can. Custom return codes. If you just say T-warn and T-die, it's gonna give a generic error. You don't know why. But you can put a message in there, and you can put a written code in there too, and say, we've written an article over there. If you want, you can leverage that. Where we were like, okay, if it's a system error, start the return code with 5 or something. If it's a data-related error, start the return code with 4. Right? You can do something like that. Okay, and we have an article over there which talks about that, how you can generate return codes, so that a production support, if he sees a job fail, like it's running from Control M or Title or something like that, and they see the error message, they don't know, they're not developers, right? If they see a generic error, they don't know what to do. Now, if they have a code, they'll understand. Oh, I need to call the database people. or I need to call the developer because there's something wrong with the error, something wrong with the job, right? Or I'll call the system people, basically because there's something wrong with the server. Job server is down or something, right? So if you have custom written codes like that, it'll help you to easily debug some of the issues, right? So that's one really good best practice, I think. So, any questions? So far, so good. All right, 10 more, I guess. Unsub job. So. You guys are already, who are already using Talend Studio, already know about uncomponent OK, sub-job OK. It is obviously very important to understand the difference, okay, between unsub-job OK and uncomponent OK error. Can anyone tell me the difference? Unsub-job OK, uncomponent OK error. There's a difference, but so do you guys use unsub-job OK on sub-job error, right? And on component OK error also, right? You guys use that. So do you know? Anyone know the difference? Go ahead, please.
So on sub-job OK, it passes only when the sub-job is completed.
Right.
Component OK, if an error exists in a particular.
It's a specific component. Right. Exactly. So. If you remember the first slide where they had the top to bottom, left to right and top to bottom, right? So the top to bottom links are probably on sub-job OK, right? So if you want to bundle your source and target in one sub-job OK, and then you want to orchestrate. You want to say, okay, the second job should run second pipeline for reading a different table or doing something else, or reading from a MQ, reading from a queue or something. If you want to do that, you want to connect them using some sub-job OK. Obviously, the uncomponent OK error is at the component level, obviously. And the other one is at the sub-job level. Okay. So yeah, I mean, as long unsub job also one of the key. I mean, this is extra information, but this is actually, if you look at the code behind it, all the sub job will become part of one method, one Java method actually. So if you are, one of the things which we saw is, developers did not, they kind of built a big monolithic job in one single job, right, and one big sub job, right, and it was giving a Java 65,000 exceeded limit error. They were simply because they put all this in one sub job, right? So you will get that error if you have a lot of components in one single sub job. So because it's not a Talend error, it's really a Java cannot parse more than that much, more than the code that you're giving, right? It's not really a Talend problem. Yeah, I mean, try to compartmentalize your code. Okay, don't put everything in one huge sub job. Okay. All right, moving on. Number 7, we talk about job loop. So this is we're talking about the main loop, right? We already talked about the pre-job. We already talked about the post-job. Main loop is what is actually doing the main function of your job, right? So obviously there has to be a main loop in every single job of yours, right? If without a main loop, the job is not doing anything, right? So that's the way to think about it. You're putting the pre-job, you're doing the main loop where you're doing the actual transformations. You can have sub-loops too. You can have other main loops too, like secondary main loops also. That's fine, but mainly pre-job, the job loop, the main job loop, and then the post-job. Okay. All right. This is a comment from the prophet Marcus Lemonos. So people, process, and technology, right? So obviously, you need all of them working in technology is important, but without the right people, right developers, and right practices in terms of processes, technology, you will fail, right? So it doesn't matter how sophisticated the technology is, right? If you don't have the right people around it, and you don't put the right standards around it, it's gonna fail. So people, process, and technology, right? It's important. Again, we do have SDLC best practices guide here. If you guys are thinking in terms of SDLC, if you guys are thinking to go to the commercial product, and if you are thinking about having a source code repository, we used to support SVN, and SVN still works, but use Git, like Bitbucket, GitHub, those kind of different flavors of Git. Use those. Use that. Okay, Git works really well in terms of collaboration and also managing the conflicts across the same job, across multiple developers. Your branching and tagging is cleaner. There's so many different advantages that you get with Git compared to SVN. Okay, SVN still works. If you're on SVN, if you want to use SVN, that's still okay. But we recommend, our recommendation is if you're just getting into, trying to find if it's SVN or Git, our recommendation is just Git, period. Okay, there's no, going back on that. Yeah, the Git works very well, and we're seeing a lot of customers who, and in fact, our Talent Cloud only works with Git. It does not even work with SVN. Only Git, basically, Talent Cloud. All right, best practice number 9. We'll talk about managing workspaces. Workspaces are your local workspace. I'm talking about local workspace when you install the studio and you're connecting to your TAC if you have or a licensed product and you're connecting to TAC. Your workspace actually gets synced with the SVN or the Git repository, right? It actually, whenever you log in, it is looking for updates in the workspace. It's going to, through TAC, it's going and talking to the Git repository, and if there's any changes, it's bringing back to your workspace. Okay, so our recommendation is there's a default. There's a default location when you install Talent Studio on your machine. It's a default location. That might not always be the right location. Okay, you might want to, again, standards, right? You might want to come up with a standard to where you want to put your workspace on each developer machine. Okay, it could be a shared drive somewhere so that you don't lose the workspace. I mean, the Git repository is still there, but sometimes the workspace, you still want the workspace to have, because it's yours. You build your jobs in there, so workspace is still important. And the recommendation is try to come up with a standard where you can actually put that in a shared drive so that all the developers' workspace can be seen over there, right? If something goes wrong, you can quickly go back and reload the workspace, and you're good to go. Basically, if your laptop fails or things like that. Okay.
Separate for each user, right?
Say it again. Yes, it is. Yes. All right, moving on to number 10, reference projects. I know there's some Informatica developers here. This is really like a shared project or shared folder in Informatica. Okay, so again, this also goes back to reusability. Okay, so some of the common logic, right? You can let's say, so this is really for enterprise customers, right? So I've seen people using reference projects where, okay, we have 15 different streams of projects going on. Data lake project, MDM project, data warehousing, sales data warehouse, commercial data warehouse. There are multiple streams going on, right? So, and the joblets, which I spoke about, that is only visible within that project, right? But let's say in error handling, right? Error handling, it doesn't matter. It has to be the same across all these different projects. So how would you do it? Because error handling, that joblet is only available within that project. It's not visible across all the projects. So what you do is you take that and dump it in a reference project, Okay, there's something called reference project. When you create a project inside TAC, right, it gives you an option. Is it a reference project or it's a normal project? If you check on reference project, it's gonna make it a reference project. And reference project will be available in the studio. If you log into the project, that reference project will be available for you as a read-only project over there. All you can just drag it, and it'll become available for you in a project. Okay, but the project should be obviously should be given access. Okay, so the reference project, when you click on that, you have to say which all the projects will have access to this reference project. Anyone using reference projects here? Oh, there you go. Okay, good. So go ahead, please.
No, so should it happen at the time of creation, or can we?
No, it has to be during creation. Yes.
Cannot be done in later.
Oh, the question is, can you make a normal project? Can you change it to a reference project later on? But you don't want. That's a big risk because.
So like if it has more useful components for other projects.
If I think about it, you should be able to do it, but I don't know why would you do that.
Copying into another project, that's what
I would try to just create it in the project and then make that a reference project. Copy whatever reusable logic you have and copy it in there, and then try to make that reference project. That's what I would do instead of making the existing one reference project.
create a new project to while.
Exactly. Yep. All right, moving on. Object naming conventions. We talked about this development standards, right? Development standards. This is big, right? Naming conventions for everything, right? For everything. For starting from how you should name your job, how you should name your components, how you should name your let's say your what else? Your joblets, right? How you want to name your directories, the folders. How you want to name your context variables and groups. That's critical, right? So you have to come up with a standard way to do that. You do not want. Typically the team lead of the talent team lead. That's his responsibility, really. He's the person who has to define these standards, or the manager, whoever. But he has to define the standards, and he would need to come up with that, and he has to make sure. The developers are following following these standards. Okay, naming conventions. Okay, it's very. Believe me, if you have hundreds of jobs, right? If you have hundreds of jobs, and someone says this job failed, and go in and fix this and try to figure out why this job failed, right? And if you are going into the project and you're looking for that job, if you have a common naming convention, it's easier for you to understand. Typically, what I've seen is also the target target table name that you're loading. You can put that in your job name if that's the only target, that's the only table you're loading, right? And things like that. Okay, and also you can start off with, like, say, higher level, right? The project name first, right? Job underscore the project name first, and then next within the project, what are you doing? What it could be different things within the project, right? It could be like the table name, right? You can add that to it. So start from the high level, and the string can go actually for job name underscore this underscore this underscore. It could go on to like 5 or 6 different levels. So, but it's great. It works perfect. I mean, you have to do that. It doesn't matter. I mean, it'll be a great value add. You should really. I mean, I keep saying you should really think about, okay, what will happen in next 10 years? Can someone be able to understand what is going on? Will they be able to easily know what this job is doing, right? You have to really think about 5 or 10 years down the road. I was at PepsiCo, and their Informatica environment, it's been there for, like, I don't know, 20 years there. So I was debugging some of the jobs which were built like 15 years ago. If the naming convention was not there, there's no way I could know what was going on in there. And I don't even know which folder should I go to. I don't even know what table is loading unless I actually open the job and actually understand, this target table, this, it'll be very, very tough for me to know where to go. if I do not have the naming convention. That's just one great example. But this happens all the time. You really have to think like 5 or 10 years down the road. The job you're building will be there, believe me, will be there for in the 10 years, right? So think about what you can do. Anyone can, in 10 years down the road, can you actually understand what is going on, right? Number 12, we are talking the project repository. So on the project repository side, there are obviously a lot of things going on in there, right? The job designs are important. Where jobs are located, there's the context variables. If you're not using context variables, you have to, right? And it is really it's important for you to guys to use the context variables and context groups, right? And also context groups helps you to to put in variables, right? You can dynamically change some of the variables in your code if using context variables. That's basic programming 101. You got to use context variables, okay? And also it's also used for your deployments, right? You have the database host name in dev. You cannot use the same name, obviously, in QA and production. You would have to change it, so you define it in a context variable so that you don't have to go in and actually change it again. You just move the context variable across environments. You're good to go. So understand, if you're not using it, use the context variables. Those are there for you to use. Metadata. Metadata is critical. That's one of the things that you're getting, as opposed to, like, let's say you're doing Java programming, right? Okay, so there's still a lot of companies out there that are using ETL, using Java or .NET. Okay, what are you getting using ETL tools? You're really getting metadata out of it, right? It's really tough to parse a Java program and find and capture metadata out there, like database name information and all that. You have to write in the program to do that, really, right? But for you, using metadata, right, you can, all the metadata has been stored, and you can use that. You can use that for so many different purposes. So, for example, the whole metadata, data governance and metadata management is popular, right? So right now, a data governance, the peak of the data governance, a really mature customer of who's doing data governance will have metadata management. What that is you're taking metadata from all these different systems, enterprise level, right? You're taking your sources, you're taking your jobs, you're taking your metadata from your databases, from data lakes, and you're stitching them together. You were even stitching together the logic which goes into this pipeline from end to end. So as an enterprise architect, if you everything from A to Z, right, from this system to this system, for all your enterprise systems, all the metadata is right then and there. It's easy to know. Okay, if I want to change this on your target side, if I want to change a column, right, on your data warehouse, right, what all other systems do I need to go and change? Right? It's a powerful information. So this powerful information you can get using metadata. So use that. Use metadata for that. And ETL tools, you're using your ETL tool, the primary thing, other than easily be able to code and other things. But from my perspective, at least from the data governance perspective, metadata is critical. So build that metadata, and you can do a lot of good things with metadata. Okay. All right. 13. We are talking about version control. So in our Open Studio product, we have something called major and minor, right? Major and minor versions of the studio of the job itself. What it does is actually when you create a minor version, it actually copies the job. It actually creates a duplicate of that job, okay? Which means that it's really going to, if you have 10 jobs and you have 20 versions, that means that you have 20 different jobs sitting in your repository, and your repository can get really slow, honestly, believe me. So if you are a commercial product, do not use the major minor version. You have to use your branching and the tagging methodology to track the versions of your jobs. Okay, Major minor version was actually was for Open Studio users, not really for commercial users. Okay, so if you are using that, do not use that. We have knowledge base articles on what's the best way to use Git in terms of Talend, right? If you're using Talend and if your source code repository is Git, what is the best way you can branch? What's the best way to to manage your repositories? Okay, you have to create. You should not create one. You should not just create one repository in Git actually, and depending on the number of jobs it has, it can slow down your studio. You have to create multiple repositories in Git, and each Git repository will be one project. Okay, so things like that. So there we have some best practices for that. So follow them if you are not already doing those, because that will impact your whole SDLC process. It will impact the developer collaboration. It will impact your developer productivity. It will impact your release cycles. It will impact your QA cycles, the way you're doing it. So yeah, get that down on paper. Get it down the first time. I mean, while you're doing the first project. Yeah, of course. Yeah. You can go to help.talend.com and say Git best practices. You'll find it. Yeah.
We really encountered this issue.
Yeah.
Because when I was developing jobs, I just, for every change, I used to go implement the minor version.
Yeah.
And the sync with Git was
It's taking a long time, right? Because your repositories became bigger and bigger, right? Because it's actually copying the jobs, right? Yeah. So,
And,
sure,
question.
please.
What's the difference between a duplicate and a copy?
Duplicate and a
So you have both the versions, right? You can either duplicate a job or make a copy of the job.
okay.
In Studio, it gives you both the options.
Okay.
So I blindly do the duplicate, but I don't know what's the difference between.
At least from what it's saying, I don't know why would they give two options. I don't know. I don't know.
Copy a job, you will use that option to copy.
There's also a copy option, right?
Not for job level. At component level, you have copy.
No, there is, you have duplicate option and a copy option.
That's a good question. I don't know. It seems like duplicate and copy should do the same. They do the same thing, right? They're just okay.
Final outcome.
It's the same thing. Okay.
Clips, you almost always going to duplicate and not copy. Copy, you end up having stuff not working.
Yeah.
That's an
I don't know.
Eclipse issue.
Oh, okay. So can you repeat that, please? Sorry.
In Eclipse,
Okay.
you typically want to use the duplicate, even though duplicate and copy is available, but Eclipse has problems with copy.
Okay.
And it'll corrupt some of your functions.
Okay. Interesting. I didn't know that.
It's an Eclipse issue.
It's an Eclipse issue. Okay. Okay. So all right. So if you're using SVN, there is no merge in SVN. Only Git provides merge, right? Merge as in like, okay, you developed a job and you're doing it in local and someone else has already changed it and committed it, right? And then you already have the old version there. At that time, you want to actually merge the changes from two developers, right? That is called merge. And merge, SVN does not do it. Only Git will provide that. So these are one of the advantages that Git will provide you, okay? 14, memory management. That's a memory chip over there. So this is a long topic actually. So, but the core, what the slide is saying is you have to design a job. When you're designing a job, the memory settings are important, and there are many factors which impact that. Okay, obviously the number of records that you're reading and loading matters. How many lookups that you're doing, because the lookup is basically it's going to take and put in the memory, everything sits in the memory. So how many lookups you're doing matters. How many parent-child job nesting you're doing also matters, right? So memory, you as a developer, you have to really think about, okay, in production, what's going to happen, right? you have to really go to production and say, okay, this table has like 10 million records. Am I building the job so that the job can accommodate so many records? You have to really think as a developer in development only, okay? Because you don't want to run through performance issues when in production, right? You have to think about that in development only. Performance is a big thing. One of the foundational precepts that we saw, that performance is a big thing. So you have to think about how you want to split them, right? If you have 25 million records and you're looking that table up and your job server only has 8 gigs, I don't know, would that work? Maybe not, right? So, and there are other options too, right? We'll talk about parallelization, how you can actually control some of that a little bit, but you do have to think about, how much memory will your job need when you're running in production. It also depends on, how many jobs. Sorry, you have a question?
Yeah.
Go ahead, please.
Just real general, like, okay, so let's say you have 1 billion rows, right?
Okay.
You got an 8 gig memory on your server.
Right.
And you're going from Oracle to SQL or whatever, 2 different databases. You're pushing the data across, right? I go with the Microsoft world, and SSI, it captures it inside the SSIS server. In the Talend, you have 1 billion rows. How is it controlling those buffers? And can you control it?
It's not. It's not controlling.
So it just piles all that in the
Yes.
memory?
Yes.
So, is there a way, okay, let's say this is regular code, like in SQL Server, you can run a loop, right, of every 1 million rows, whatever, and it won't use up all the space
Yep.
and that kind of thing. Well, that's actually transaction logs, but the point in memory, can you run, if you're going to do 1 billion rows, 10 billion rows, 50 billion rows on a small server, how do you do that intelligently and create a package that can do that?
Yeah, you actually answer your own question. The batching, like you said, right? You can create loops, right? I actually wrote a knowledge base article in this specific question simply because a lot of people were asking the same question. So batching, right? So you loop through it. Yeah, you loop through it. You can again, it's programming, right? You can set the start and the end date, end record numbers, right? And you can send that as an input to the SQL query, right? Let's say if you have a customer ID in there, right? Or or a date, right? You can actually put that the last process date or the last process ID in memory, and then you can send it back to as a variable, and you can update it so that it can take, the next batch will start. So the looping thing, again, earlier I worked for Informatica and SAP Data Services. You cannot do that. It's really, really, really tough to do looping in Informatica. Okay, and when my boss said go and write the solution for this, I was like, I don't know how to do this, because I came from the Informatica thinking, and he's like, use the looping. And I didn't know there was looping in here.
You said at first the loop was good, then you just said that you couldn't do loop.
No, you could. So in Informatica, you cannot. Informatica, yeah, I'm talking about different tools. So
When you say looping, are you talking about checkpointing? So remembering where you finish up the time sequence?
you so checkpoint. You're talking about checkpoint. Yeah, I mean, logically yes. But what I'm saying is, let's say you have 10 million records, right? You can read the first 1 million records one time, and then go back and run the.
Physically break it up a little bit.
Exactly, but it's the same job, right? You're not actually having 10 different sources in there. It's the same job. You're just running. The SQL is generating. It's actually different every time it runs. So you can make it as dynamic as possible, right? So you can do that. So the answer to the question is batching. That's the way I would do it.
Every time it pushes and it finishes that iteration,
And then comes back.
the memory is brought back.
Yep.
And then you go again.
Yep.
And the same thing with, let's say you have a main job that's has a bunch of T runs in it.
Uh-huh.
Not parallel, but just in sequence. Let's
Right.
say it's 100, call it 100 packages.
Right.
Let's say pretty hefty packages.
Right.
Every time it runs through each job, and that job finishes, the memory is given back. Is that correct? Or is a memory, or if you have 100 jobs and one, you call 100 jobs, you're going to be really in trouble trying to run that same job.
Right. So that's why I would try to use that different JVM setting. I told you about that independent child process checkbox, which means that the next sub job will run in a different JVM, and that job is finished. It's gonna release that memory.
Okay,
So use that. Use that setting if you have that requirement.
that's how you get around the low memory.
Yep.
Otherwise, you
That's
just
what
pile up the memory.
it is. So
Parallel.
yes. There's no buffering in Talend of memory inside Talend. Right.
Is there a limit on the memory?
Limit on the the limit is your job server. How much ever memory is on the job server. Or if you're running on the studio, obviously the studio machine becomes, you need enough memory on your studios. That's why.
Limit is your heap size that you're given, the max heap size. Whatever is the max heap size
yeah.
you're given in the JVM, that's your limit. So
Right.
you can change that.
Right.
But there are some JDBC parameters for batching. You probably want to look into that. You can adjust that. And someone can mention buffering also on the base. So there are a few things that you can tweak.
You could also take those and load level across a couple of servers. You can take your batching and load level those across a couple of Talend servers.
You're talking about the virtual job servers, right? Yeah. It's a concept of virtual job servers. Again, this is only for commercial, where you can tie together, like cluster them. You can cluster 2 job servers and then make the job run on the virtual job server.
Do you have 2 instances of the job running on one on each server? Or
No.
one instance of the job sharing the 2 servers in the cluster?
At any point of time, the job is running on only one server. Okay, but what I'm saying is when you're running the job, what TAC can do is, okay, this job server is really busy. I'm going to run this job on the other server. Or this job server is down. I can run this job on the other job server.
This is a perfect example of being able to run a sub job from a job. You could take that and batch it in those sub jobs, and then have TAC manage which server it's going to run on. You could have multiple servers running that.
You will assign job server, right?
It is
How will you
self-managed,
dynamically change?
self-managed.
Won't change dynamically. If we have multiple servers,
Just load
job can have only one job server.
Yeah, but you can you can tell the job to run on a virtual job server. You can create inside TAC. There's something called virtual job servers, and you can tie together. I think more than 2 servers you can tie inside one virtual job server.
Yeah, we have multiple servers, but for a particular job, we need to assign the
Yeah.
server.
Yeah, instead of the server, you would assign a virtual job server. Just one. Instead of assigning one job server, you assign a virtual job server. Virtual job server is a cluster of job servers within one virtual job server. Yeah, that's why it's called virtual. It's not real. It's just virtual. Yeah.
So adding to his question, so suppose you're running from Oracle to SQL Server and you have 100 million rows.
Yeah.
And you have, say, only 8 GB RAM on your system. You said you're going to fill up your memory, right?
Yep.
What if I have a commit interval of for every 5,000 rows or 10,000 rows? Won't it flush them from the memory once those 10,000 rows are committed in the target and release the memory?
If you're doing there are no lookups, right? There are no lookups. You're just basically doing Oracle to SQL Server, and you're saying that if at that time it's going to read only the number of records that it can that the memory can take, right? And you're
That's the fetch size, right?
yeah.
It's a fetch size and but the commit interval you're talking about is to release any storage on the source side. Because otherwise it's going to be keeping all that stuff in memory.
So even if I have a 8 GB machine, 8 GB job server, it should be good enough to run 100 million records or 200 million records. Right?
It should be possible. But how many JVMs you're running at that time also depends, right? How many jobs you're running on that server.
Yeah.
So finally, how much heap size you can give the JVM. get that heap size.
Yeah.
You can specify max heap size of 8 gig, but you may not be able to get that.
Yeah.
Can I follow up on that question, or similar, maybe it's not exactly the same, but going back to that 1 billion rows, right? And if you don't commit, okay, if you're not doing auto commit, and you're gonna commit after the billion row, right? After the whole thing's done, even though it's a loop, right? And you're going to do a commit at the end, okay? So how does that affect everything? I mean, the commit generally would happen, it's on the transaction log on the target server, right? So if I'm putting in a billion rows in SQL Server, that transaction log is getting hit.
Right.
And it's getting ready to roll back, it has to, or commit. So if I'm not committing on every one of those loops, right, a million rows or whatever, is that going,
You got to commit.
Is the transactions going to be affecting memory and talent?
No, that's not a talent.
Yeah, it's
That's
on the target side.
totally a database side.
That's what I'm asking. It's only on the target side.
Here, the focus is primarily talent, right? So talent is now dealing with the source component, a target component, right? So whatever happens in the talent world is what the JVM is interested in. So from a talent perspective, whether you read it as a stream or a batch of records, it takes it as an input, and whatever it's supposed to do, it will do and send it to the target.
Right, inside the buffer is sucking up memory. It's taking up memory when it gets to the buffer.
No, what's getting buffered is all component specific, right? Now say, as part of your job design, say you're trying to cache. So it's all component specific, say, or you're trying to do a sort, right? They all add up as part of the buffering mechanism. But if your job is simple, you're having a source component, reading from source, directly writing to target. If that's your design, then it just pushes the stream.
What I thought I heard that it does take up memory when you push a bunch of rows across.
It does. That's where the concept of batch and arrays comes in. So by default, whatever it is, right, 100 rows or 1,000 rows, that is one unit of work. So it will read down 100 rows, push it to target, and it will repeat itself.
What might affect it is in the JDBC, if you set a batch size of 10,000 rows, it will batch that up and then sends the batch to the target. So
Right.
if you have a high batch size, that much is going to be retained within the tablet.
Right, I understand that. What I'm trying to say is that if you don't, I'm talking about the commit at the end on the database.
Commit is a database property.
Yeah, that's a commit size.
That's all on the database.
Yep, that is, yes, yes. Sorry, you were going to say something.
So I was saying your database probably can't commit a billion rows at a time, so you need to do like 1 million or 100,000, and it'll commit several times, and you'll eventually get to the billion rows, but it'll never complete committing 1 billion rows at a time on your database.
Also, it depends on what the database is doing with other users, other sessions.
All right, I think we need to move on, so we can have another discussion if you like, but sort of makes sense?
Right, yeah.
Okay, thank you for that. 15, I think this is the last one. So there is something called dynamic SQL syntax. So you can actually completely make your SQL query that's being generated on the database completely dynamic. Okay. What I've done with that knowledge base article, which I just mentioned, was the table name that I'm querying, the column names that I'm querying, all that I actually put it in the context variables, so that I can change it whenever I want. So the database query itself, the table name, the column names, the where condition, all that can be parameterized. Okay, but again, you will. It gets a little complicated sometimes. For me at least, I need to understand, if I go to the query, I need to understand what is going on. Sometimes I have to open the component and see the query itself. You won't be able to do that, right? You have to go to the context variables and see what context variables is using for this, and form your own query, right? So that option is there if you want, but I don't want to oversell it. Okay. All right. 16 is parallelization options. There are many parallelization options. We call them the subjobs. We talked about the subjobs. There's also T-parallelized components, right? You can use them, right? This is really for performance, right? You can use them. Parallelization has to be as also you have to think twice before you implement a lot of parallelization techniques in your job. Sometimes it can really be bad. It can actually perform worse than it was, right? If you're not thinking correctly, if you're not doing it right way. Okay, so it's a trial and error method. Performance tuning is always a trial and error method. You have to implement one method and see if that works, and then if it doesn't work, you have to add some another component, things like that, right? So you have to. It's very iterative. Performance tuning is right. So and you never want to overdo it also, right? You can control it using job servers. Like I said, virtual job servers. You can control it using multiple JVMs. You can control it even in the tag using execution plans, things like that. All the options is the next slide, I think. Yeah. There you go. So some of the stack that are available for you to parallelize. All right, let's move on. Some secrets to building. So obviously the use case and technology and methodology are important. Yep. And I'm going to leave. Okay, this slide is basically telling, take some action. Hopefully you'll gain some knowledge and you will put some things in action at least after you go back to your work tomorrow, hopefully. And that's it, I think. Yeah. That's about it. I think that's it. Thank you very much. Appreciate it. Maybe.